Hi, my name is Angela and I work at Onkaparinga Libraries in South Australia. And we're very lucky today to have Jonathan Drori with us, all the way from sunny England. It's sunny over there at the moment, unlike here. So Jonathan has got a presentation he wants to share with us, which is going to be awesome. But before we get started, I just wanted to say thank you to obviously Jonathan for joining us tonight. Morning there for you, but nighttime for us. Thank you for Lawrence King Publishers for passing our emails on to Jonathan, and also thank you for attending tonight. We have got Jonathan's books in the library. We've got both of his books, so you can put them on hold by excellent. Do you want to make a noise so they can see you, because I had that problem last week? Say hello.
Hi.
Last week we did that, and when I looked at the recordings, there was no image because the recording picks up who's talking.
Oh, I see. Right.
Yeah. So if you wanted to put these books on hold, you can do so at any library in South Australia. You can be in person, on the phone, or on our website. You can also purchase these books from our bookstore Dimmicks at Glenelg, and they always stock all our books, and we like to give them a mention because they've been awesome over the last couple of years supporting all our online author talks. If you would like to ask any questions of Jonathan, at the bottom of your screen you will see a Q&A button. You can ask your questions there and I'll ask Jonathan any at the end. And if you can't see a Q&A, just hover your mouse over there and that strip that's at the bottom will appear and you will see it then. So without any further ado, I'll pass you over to Jonathan. Thank you, John.
Thanks very much, and good evening. Hello. I'm going to share my screen, and I hope this will work. And if I do that and this, so I'm hoping that if you could just confirm, Angela, that you can see the whole screen and my laser pointer. And
I can, yes.
Yeah, good. Okay, and you're not seeing my my notes or anything?
No.
Good. Okay. Well, look, what I plan to do is talk for about 40 minutes or so. And given that this is quite a small live audience, but there'll be more people who watch in the recording, I hope, then if you have an urgent question, then you can sort of type it in and maybe we can interrupt and answer it. Here's where my interest started a long time ago in plants. This is me with my father in Kew Gardens outside the Palm House, and that's me, the little guy. And there he is, a relatively new immigrant to the UK from Eastern Europe, and that's why he's wearing a suit on a Saturday afternoon to go and see plants. And he used to sort of teach me about plants by feeding me bits of them. And I remember him giving me a lick of an opium poppy once, and my tongue going ever so slightly numb. And this was his sort of way of exciting the kids about plants. But it's something that stayed with me, was the sort of combination of science and beauty, and also the human story of, in this case, when I told my teacher, she sent the social worker around to see my mum to see if they were feeding me with drugs. As I sort of had the opportunity to travel, and I became a documentary filmmaker and then was on the board of the Royal Botanic Gardens Kew, I had the opportunity to see the incredible kind of diversity of plants. So everything from this sort of amazing quiver tree, a relative of the Aloe Vera in Namibia, to these pandanus fruit from Papua New Guinea, the ridiculous wax palm, look, that's a person at the bottom there, in Colombia, these fantastic shapes and sizes and so on of and kinds of plants, incredible diversity. And they've all evolved to fill different environmental niches. There's woody nightshade, which is quite a sort of well-known poisonous plant of England. And that's an interesting one because it's a member of a family that we'll come back to. They're called the solanums. You might recognize these from Australia. And then Rafflesia from Indonesia. You've got a variety of ginger here, and this amazing, very ugly looking plant, again from Namibia, called Welwitschia. About 40%, or that's 2 out of every 5 plant species, are actually at risk of extinction, mostly because of what we humans are getting up to, either with habitat loss or climate change caused by the use of fossil fuels. So I was on a seed collecting expedition in the Andes in Chile, and I had this sort of odd experience where I was standing looking at a bird like this one, which is the world's largest variety of hummingbird. And I was just sort of marveling in this hummingbird, which is about the size of my fist. And as I was watching it, I called over one of the botanists, and I said, "Shh, look at this amazing bird." And he said, "Oh, it'd be fantastic when that bird gets out of the way and I can see the plants properly." And for him, he had this sort of animal blindness. And for the rest of us, we tend to have plant blindness. We tend to see only the things that move quickly, or sort of concentrate much more on animals. And it made me think, these are baobabs in Madagascar, it made me think how plants have to feed and defend and reproduce themselves while being rooted to the spot. And so I'm going to talk today a bit about that feeding, defense, and reproduction as a kind of theme, really. So you might have noticed that pot plants, if you've got one at home, get bigger and bigger and bigger without you ever having to top up the soil. So the question is, if you ask people, where does all the stuff come from that makes up a plant? Most people will say actually out of the ground. But it can't come out of the ground because you hardly ever have to top up the soil. You maybe put in a couple of drops of baby bio or whatever you have in Australia, sort of plant food. But there must be something else going on because the plant gets bigger and bigger, but the soil doesn't go down. So all the stuff comes from 2 sources. Two sources. One is carbon dioxide from the air, which comes through the leaves, which is heavy stuff actually, and the other is water. So if you need convincing about this, let me show you this. Here's Spanish moss, or Tilanzia. It's not actually a moss and it's not actually Spanish. It's a cousin of the pineapple, and it grows hanging on trees in the American Deep South. Very much the look and feel of Gone with the Wind, which is appropriate really because it gets what it needs from the rain and from the air. It doesn't have roots that go into the tree. The extra nutrients it needs come from dust in the air and maybe the odd bird dropping. And it's very, very odd curly stuff. It used to be used for stuffing mattresses, and you probably see people are collecting it in this old motor car. They used to stuff car seats as well with it. It looks like they got a bit over enthusiastic in that one. And as you can see, it also grows on electricity and telephone wires in midair. In other words, no soil needed. And so, this is kind of proof that plants can grow just out of the air as long as there's moisture there. And those are the 2 things that they need. I'm just going to read you a little bit from Around the World in 80 Plants. And I'm going to read you a little bit about Spanish moss because it's a rather interesting plant. And in fact, while I do the reading, I'm going to just put up one of the beautiful illustrations from Lucille Clerc, who's illustrated the book. An eerily iconic plant of the swampy southern states, Spanish moss has skeletal finger-length leaves that curl together into chains, forming elongated grey-green curtains that drape from trees and telephone wires. Victorian travellers to the deep south wrote melodramatically of trees that swept the cobwebs from the sky, or appeared to them as witches weeping in the moonlight. It is indeed a strange plant. Spanish moss is also used to stuff hoodoo dolls, charms believed to ward off evil and bring good fortune to oneself, or more rarely, misfortune to another. Hoodoo is a spiritual offshoot of Louisiana voodoo, a system of beliefs that developed in the southern states from the traditions of the West African diaspora transported there in the 18th century. The link with hoodoo talismans contributes to the plant's creepy reputation. But the people who craft these dolls may be playing on more primitive emotions. Perhaps Spanish moss and the swamps it inhabits embody nature untamed, rampant, and beyond our control. So water carries chemicals around the plants and keeps the tissues sort of turgid. But along with carbon dioxide, it's one of the two vital ingredients in photosynthesis. And so it's actually part of the chemical reaction as well as carrying things around the plant. And plants will do anything to get water. Most striking, of course, is when water is short. So in deserts, and you have plenty of deserts in Australia. These are the dragon trees of Socotra, which is off the coast of Yemen. And they've evolved to funnel every tiny little droplet of water down towards the center, where the roots can make use of it. Cacti protect their precious water with spines, but they also have a special kind of metabolism that allows them to take in carbon dioxide in the cool of the night and then chemically store it until the next day, when the sunlight allows them to do their photosynthesis thing. And that way they don't have to open the tiny pores in their leaves during the day and risk losing water vapor. And look at this aloe vera plant, the one that's used in cosmetics. Tough armored leaves and water stored as a gel inside. Now, this is one that you're probably familiar with. This is mujar. I think it's also called the Western Australian Christmas tree. And look how it's sort of bursting with life. Even in a rather dry environment around. And mujar has a dirty little secret. It's a parasite. It draws water and other trace nutrients that it needs from other plants. And technically it's a hemiparasite because you can see it's got green leaves, so it does do some photosynthesizing of its own. But it can send out its roots over very, very long distances, 80 meters or more. It attaches a collar around its prey. I think you could probably just see it there. It then deploys these sort of incredible hydraulic secateurs to sever the host root, and then it attaches itself instead. And the way that the mujar root sniffs out its target is by following a kind of molecular trail of particular plant hormones. But some of those same chemicals are present in some plastics, and some of those plastics are used for insulating electrical cables. So you guess what's coming next. For that reason, the beautiful mujar has been known to attack and sever telephone wires. And there's something about that I rather love, the idea of plants fighting back. So if water is one half of the photosynthesis equation, the other half is carbon dioxide. And carbon dioxide mainly comes into plants through the leaves. And leaves have evolved in all these beautiful, amazing sizes and patterns, all evolved to fill different niches, if you like. And each leaf is a chemical factory. One of my favorite leaves is the giant water lily. This is Victoria amazonica, named after Queen Victoria. And I love the way it's evolved with spouts so that it doesn't get waterlogged. Can you see those? And the system of load-bearing struts underneath was the inspiration for the Crystal Palace, which is where the Great Exhibition in London was held in 1851, 3 times the size of St. Paul's Cathedral. And it enables the plant to efficiently use the water surface, but also has another important purpose, and that is for every botanic garden in the world to supply the ability to do one of the great photo cliches of our age, and stick a baby on top of a on top to take photos. So another of my favorites with all sorts of strong links to water is the lotus. This is a fabulous, fabulous flower, and it makes anyone who's grown up in South or Southeast Asia to go really quite misty-eyed. So just about all parts of this plant are edible, and actually they're rather good. It grows in water, often quite murky water, and the seed head looks disturbingly like a shower fitting. And there's an amazing underwater breathing system for the roots, which relies on temperature differentials and all sorts. Now, As you've probably noticed if you wear a raincoat, when water lands on it, the water has surface tension and forms globules. And there are certain surfaces where water does that really well. And one of the best surfaces that we know, better than almost any raincoat, is the lotus leaf. And this is called the lotus effect. That what the lotus leaf has are these tiny, tiny nanoscale dimples that you can only see with an electron microscope. And those little dimples actually cause the droplet of water to sort of sit above the surface of the leaf. It doesn't wet it. And that means that these water droplets can all sort of sloosh together. And as they sloosh around the leaf as it spins in the air, as it sort of wafts backwards and forwards, it sweeps up any little bits of dust and fungal spores and things like that, keeping the surface very, very clean. And this means that the lotus is often in religion a symbol of purity. So you find in Hinduism, for example, goddess Shakti is often seen with a lotus flower in her hands and sitting on a lotus. I think I said Shakti, I meant Lakshmi, the goddess. Let me just read you a little bit about the lotus. In Buddhism, by tradition, lotus plants sprouted in the first footsteps of Siddhartha Gautama, the Buddha, and a common mantra among Tibetan Buddhists, Om Mani Padme Hum, draws together the lotus with enlightenment and inestimable worth in one hypnotically repeated Sanskrit phrase. The lotus, perfect and unsullied by the muddy waters in which it grows, with glittering beads of water that dance and sparkle jewel-like in the center of its leaves, symbolizes the spiritual journey towards light and wisdom. And now we're at sea, but still thinking about photosynthesis. This is another of Lucille Clerc's gorgeous illustrations. And I'm going to read you about marine phytoplankton. Yep, in my book, literally in my book, they're plants. So microscopic single-celled organisms may not fit everyone's definition of a plant, but a plant's most important capability is to photosynthesize, and phytoplankton certainly do that. Most of them live for just a few days, drifting on ocean currents, suspended near the surface where there's light. Using sunshine to power the process, phytoplankton consume carbon dioxide dissolved in seawater and incorporate carbon compounds into their tiny bodies, just as carbon is stored by the wood and leaves of a tree. They may be small, but they're abundant. A tablespoon of seawater may contain hundreds of thousands of individuals. Together, the world's marine phytoplankton absorb as much carbon dioxide and give off as much oxygen as all the trees and every other land plant combined. They're also the ocean's primary producers, the first link in the food chain. Without them, hardly any other sea life would be possible. Phytoplankton are typically the width of a fine hair, but can be much smaller. Magnification reveals a parallel universe of intricate structures, the stuff of acid dreams, solitary spaceships, and implausibly geometric shapes, minute snakes and ladders, and garlands of elaborate beads on infinitesimal threads. There are thousands of different species. And here's a plant that's common in Europe, common in the Northern Hemisphere. It's all over Canada. I don't know whether you have it in Australia. It's called mare's tail or horsetail, or equisetum in Latin. It's a very abrasive plant. It contains silicates, sand effectively, which are used in Japan for sculpting furniture or polishing furniture, and we use it still for polishing clarinet reeds. But it's a very, very primitive plant, so primitive that 360 million years ago, its big brothers, calamites, were massive trees that were about 50 meters high. And those trees, which covered, or their relatives covered quite a lot of what is now Australia and New Zealand. So they were a big thing all over the world. They didn't rot. And there's some scientific debate about why they didn't rot, but it's probably because bacteria and fungi hadn't evolved yet to break down lignin, which is the sort of woody stuff in trees and plants. So these huge trees didn't rot. The bacteria and fungi took another 60 million years to work out how to break down lignin. And in that 60 million years, all these calamites and their relatives were squished and made coal. And it's that is the Carboniferous period, obviously called Carboniferous because it's full of carbon, full of coal. And all of the world's coal was formed in that period of 60 million years, 300 to 360 million years ago. Now, from a climate change point of view, it's obviously best to leave that coal where it is, rather than releasing millions and millions and millions of years worth of carbon dioxide by burning it in just a few human generations. Nowadays, dead wood does rot, and when it does, carbon dioxide goes back into the atmosphere. So building lots of wooden frame buildings is definitely a good idea, as is, of course, buying books which are made of wood. Or stocking libraries, huge libraries with lovely books is a terrific thing to do. Sequesters lots of carbon.
I agree with that.
So now we've talked about water and carbon dioxide, in other words, the food of plants, and now it's all very well photosynthesizing, but not much good if something comes and eats you before you've had time to live and reproduce. And when a herbivore or an insect sees a scene like this, they probably think lunch. So plants have grown up with all sorts of ways of defending themselves. They are, after all, rooted to the spot, literally. So you have this fantastic spines on Pachypodium plants in Madagascar. You've got the sandbox tree of Costa Rica, very spiny. The oak trees in a British woodland have tannins in the oak bark that deter herbivores. They sort of mess around with the gastrointestinal processes inside the herbivores, give them tummy aches. You've got two-part poisons in cherry laurel, so two innocuous chemicals that are then mixed together when something chomps on them and it makes cyanide. We've got the Manchineal, which grows in South and Southeast Asia and is a particularly unpleasant plant. Almost every part of it is poisonous or caustic. You've got caffeine, which I'll come back to actually a bit later, but is an interesting plant sort of poison in its way. And you might think that this is a picture of some sort of poison being exuded by the leaf in response to something chomping it, but it's actually not a poison. What's happened here, this is a very clever kind of defense. These droplets that you can possibly see here, they contain pheromones which attract the thing that eats the thing that's eating the leaf. So it attracts the predator of the thing that is eating the leaf, which is a very, very clever and wonderful thing to do. Now, here's a very well-defended plant, and I bet it's familiar to Australian people. This is the prickly pear, or Opuntia. Now, you might know it as, if you come from the Middle East, as the sabra. It's actually native to Mexico. And to the Aztecs, it was Tenochtli, the goddess of the sun. Look at these wonderful yellow flowers. It's a very interesting plant. What looks like leaves, those are actually sort of adapted stems. And what look like these thorns are actually, those are the leaves. So botanically, it's a sort of odd thing. And the fruit are edible, though, can we just admit it? They're not actually that nice. You know, they're a bit disappointing. You know, they're sort of, they don't have quite enough acid punch, I think, to be really enjoyable. But anyway, but more interestingly, these pads, once you take the spines off, are quite a popular and tasty vegetable, and are often sold in Mexican restaurants as nopal. But there's much more to this plant than just the prickly pear fruit and the something to eat there. culturally, this plant is so important that if you look at the Mexican flag and you look in the middle of the Mexican flag there, you can see there is the prickly pear. What's going on? Why is it so important in Mexico? Now, the Aztecs cultivated the plant as a source of red dye, and it is still cultivated for that even now, 1,000 years later. So the red dye doesn't actually come from the plant itself, but it comes from an insect that has been bred by the Aztecs to live on the plant. And these little insects are called cochineal beetles. Now, the Aztecs had bred these little beetles and farmed them on the pads of which they love living on the pads of nopal or prickly pear. And the accounts of the time when the Spanish arrived show the sort of farming methods that had already been developed for 1,000 years before the Spanish arrived. Now, the insects exude this sort of waxy stuff just as a sort of protective coating. So when you look at the leaves, they've got these sort of waxy patches, but actually the insects look like this. Now, in the 1500s, the Spanish were absolutely stunned by these Aztec fabrics, which were kind of bright and color fast, and the Europeans didn't have stuff like that very much. So after silver and gold, cochineal became the most valuable export from Mexico, and Spain protected its secret for about 200 years, the secret source. But eventually everyone got in on it, and royalty wanted red clothing, and the Star-Spangled Banner in the United States was dyed with cochineal, and Oliver Cromwell chose cochineal for the dye for soldiers' uniforms. And the trouble is, that meant that it got planted all over the world in the European colonies. Now, cacti don't do so well in Europe, but in some of those colonies, it did all too well. And in 1788, the governor of New South Wales in Australia introduced it. He thought vast areas of arid land, we grow loads and loads of prickly pear, we'll get those little cochineal beetles, we'll just have loads and loads of cochineal, we'll take over the world with cochineal, it'll be fantastic. Perfect, what could possibly go wrong? Well, these finicky little insects that were bred over centuries and centuries in Mexico to just sort of work really well on Mexican plants growing in Mexican conditions failed to thrive in Australia, which is just a bit different. And with nothing to eat it, the cactus spread like wildfire. And I'm sure you've all been taught about this at school. But by 1925, this is a cartoon of the period. By 1925, 100,000 square miles of valuable grazing land had been covered with prickly pear, and people tried slashing it and burning it and dumped thousands of tons of arsenic on it, and nothing worked. And eventually, in the most important biocontrol project ever anywhere on the planet, 3 billion eggs of an encouragingly named Mexican moth called Cactoblastis cactorum. 3 billion eggs of Cactoblastis were introduced. Now, this insect had evolved in Mexico to dine out on prickly pear and actually did travel. And it largely solved the problem in Australia, except, of course, those moths now have spread around the world and are attacking other cacti. And if you go around Australia, you'll find places like this, the Cactoblastis Memorial Hall. This one's in Queensland, I think, in Bunaga. And there are lots of monuments around Australia to celebrating the demise of the prickly pear. Now, nowadays, Mexican cochineal is actually making a comeback as some people move away from synthetic dyes. So it's used for textiles still, and is often the carmine color in lipsticks.
I was going to say that. I thought it was used in lipsticks.
Yeah, possibly yours, the one that you're wearing. So if you look at the ingredients on lipstick and it says carmine, that's actually cochineal. And in 1860, Gaspar Campari used it to color his famous drink, Campari. And in some places in the world, I'm not sure about Australia and New Zealand, but in some places in the world, cochineal is still used as the dye in Campari. Vegetarians beware. So that's one kind of defense. I'll come on to another kind of defense. This is a very, very common plant in Europe. This is the dandelion. And if I look out my window here, I can see we've got a bit of lawn here and dandelions. Unless you actually take efforts to kill the things, they'll appear in your lawn, which I rather like. I like dandelions. Now the seeds carry a long way, and on these sort of for people growing up in Europe, they've all grown up with the dandelion clock, right? Little kids blow the dandelion, and you know, supposedly how many times you blow is the time of day it is, right? But these seeds, they carry an awful long way, and it's only just been discovered how they carry so far, that they actually, as they sort of fall down through the air, they create little kind of vortices, which are like, it's like as if they're riding on a horizontal smoke ring, without the smoke, of course. You know, some PhD student discovered this using wind tunnels and special photography. Now, many plants have latex that, you know, to gum up insects, mouth parts, seal wounds, sometimes to poison insects. And rubber is really well known as a latex, that sort of milky white stuff. But did you know about dandelion rubber? So dandelions in their roots have a kind of latex, which is a defense mechanism. And I was surprised to discover that when rubber supplies from the Far East to Europe were disrupted in World War II, there was a huge large-scale planting of dandelions, and in particular a variety of dandelion called Russian dandelion, which essentially looks exactly the same as any other dandelion. And this is, you know, by the time they'd sort of perfected the method of extracting it, the war had finished and supplies got sort of reintroduced in the Far East. But recently, we've become much more interested in protecting forests in South and Southeast Asia. So, you know, we're looking for other sources of rubber. And there's an EU project, and also in the US, to create rubber out of dandelions and to breed better species. So it's become a bit more mechanized than this picture during the war of landladies. And it becomes sufficiently mechanized and suitable now that dandelion rubber tires, or rubber tires with a substantial amount of dandelion rubber in them, are actually on the market now. Who knew, eh? Dandelions. And here's tobacco. This must be familiar to you, at least in some form. Notice the flower. At the beginning, I said, look at woody nightshade, which is a common and very, very poisonous plant of our hedgerows here in Britain. The tobacco flower is the giveaway, the same shape. It's a member of the Solanum family, and many of them are full of very, very nasty poisons. Not least tobacco, which exudes the nicotine, which is the poison, through these little hairs called trichomes. And that effectively stops most insects from attacking it. It was originally a plant native to Bolivia, transported throughout the Americas, used sort of ritually by indigenous people, but obviously it became this huge, huge business. And unfortunately, it was a business that was built on slavery. So by the mid-18th century, there are 140,000 enslaved people, mainly in Virginia and Maryland, producing tobacco. And the tobacco aristocracy included the US founding fathers, Thomas Jefferson, George Washington. And I'm sort of conscious of the fact that you know, the British, and I am British, you know, we're at the centre of this appalling trade in slaves. So selling a highly addictive habit is an absolutely brilliant business model. But you know, it's massively profitable for the directors and shareholders of tobacco companies. Yet tobacco has killed and maimed you know, more people than any other plant, uses about 15,000 square miles of the Earth's surface that could be otherwise used to grow food or set aside to conserve forest. And I frankly marvel at the mental gymnastics of the men and women who deploy all their intelligence, their wealth, their lobbying power to present themselves and their companies as their tobacco companies as model corporate citizens. Don't get me started on the oil industry. So now here's another solanum. You look at those flowers, typical flowers, and this is the mandrake. Now, if you ever read J.K. Rowling's books, that then you'll be familiar with the mandrake, and you might think that the mandrake is some sort of mythical plant, but these are real. You know, the mandrake is a real plant, and it's been used since ancient times as an anesthetic when it was often added to wine. Look at the fruit there. I want you to sort of think, what do they look a bit like? And they look a bit like tomatoes, right? And tomatoes are another member of that feisty family. We'll come to tomatoes a bit later. So this plant has all sorts of occult associations. The shape of the root can look a bit like a person, frankly, if you whittle it a bit and sort of, you know, maneuver, it looks even more. And the story went that the scream of the mandrake could be deadly. And so it was best to tie a dog to the root. Can you see this from the 16th century? Dog to the root, and have the dog pull it out. And I think that these were possibly rumors put about to stop people stealing such a very valuable plant, because anesthetics were in very, very short supply. And the other thing that mandrake is often associated with is witches and broomsticks. And the thing is that the reason for this is likely to be because mandrake was used along with some other herbs it contains a chemical called hyoscine, which it gives people the feeling when they take it of being of flying. And hyoscine and these in mandrake and these other chemicals in other herbs were made into a sort of ointment that would be absorbed through different parts of the body. And there was a sort of you know, through the mucous membranes and so on of the body. And there was a sort of, you know, a story that witches used to apply this to themselves using broomsticks. I won't go into the detail, but that's where the sort of the flying thing would have come from. Now, I mentioned coffee earlier on, and coffee, you know, is such a familiar plant in many ways, and yet so unfamiliar. So I don't know whether you would even know what a coffee plant looks like. So I'm going to read you a couple of paragraphs about coffee. The little evergreen coffee tree began life somewhere near the forested mountains of southwestern Ethiopia, and its broad elliptical leaves with crinkled edges, shiny and dark above and pastel pale underneath, still prefer the shade. In full flower, coffee is a spellbinding but ephemeral joy. For just a couple of days, thousands of delicate white blossoms with a light fragrance of honeysuckle and jasmine can festoon a single tree. The smoothly oval fruits ripen to pillarbox red. Their thin layer of edible flesh tastes of watermelon and apricot and surrounds a pair of deeply grooved seeds that are the familiar coffee beans. By the mid-17th century, coffee houses were popping up around Europe, and in London especially, they became places for men to discuss business and politics, in contrast to the chocolate houses, which were more light-hearted and welcoming to women. Over the centuries, many cultures have developed coffee rituals, sustained by beguiling paraphernalia and nerdy choices of grind and provenance. Ethiopia has a particularly elaborate ceremony. Amid wafts of incense, beans are freshly roasted over glowing charcoal and pounded at the table with cardamom and other spices. The resulting intense, dark drink is served with popcorn. It's a delightful experience for those fortunate enough to live within reach of an Ethiopian cafe, but perhaps not just before bedtime. Now, caffeine didn't just evolve for our benefit. Caffeine, the chemical, sort of, insects really don't like it. It doesn't necessarily poison them all, but they really don't like it. But what caffeine does do is that it helps insects, would you believe, remember where the plant was. So it actually affects their memory. And so bees can more easily say that's where the caffeine plant was and come and pollinate it. And the amount of caffeine that the plant puts into its flowers is low enough that the bees don't even realize it's there. Very elegant experiments that have been done on that. And the other thing that caffeine does is that it discourages other plants from reproducing, so that the caffeine tree, the coffee tree, has more of a chance for itself. So we've talked about defense now, and the next thing is that plants need to reproduce. They need to make baby plants. And a quick and easy way of doing that is what's called asexual or vegetative reproduction. So you take a bit of yourself and effectively plant a bit of yourself somewhere else. And strawberries, even though they have flowers, and we'll come on to flowers in a minute, the main way that they reproduce is through suckers. So they just sort of send out a bit of themselves and then grow from that. Aspen trees do the same kind of thing. So all these aspen trees are clones of each other. They're all a bit of, literally a sort of chip off the old block. Now, the advantage for the plant is that it's very quick. So if you can't make flowers, or there's nothing around to spread pollen, or there's been a fire and you need to quickly repopulate somewhere, then vegetative reproduction, asexual reproduction, is the way to go. It's really quick. And it's useful for growers because you know exactly what kind of plant you'll get. But there are disadvantages of this as well. And one of the disadvantages has been obvious with the potato, which is largely spread by taking bits of itself, in other words, the tubers, and we plant them. The tubers are the underground sort of root stores of carbohydrates. So most potatoes are not grown through pollinating the flowers, making the fruit, getting the seeds and so on, which is the sexual reproduction. So potatoes, there are lots and lots and lots of different varieties. The center of the diversity is in Peru, but there have been times in history, and you probably know where I'm going with this, where the potato, because it's so full of calories and can grow so quickly, from tubers, rulers saw advantages in Europe of a crop that could produce so much nutritious food in such a small space. The French ostentatiously posted guards around fields to make people think that it was super valuable. Frederick the Great of Prussia held a public potato banquet. So if it was food fit for a king, then it would catch on big time. But this is a cloned crop, very, very vulnerable. And the Irish planted the Irish lumper potato. And of course, because every plant is the same, it meant that, when one of them was attacked by a fungus, all the other would be vulnerable as well. And this fungus or fungus-like little organism called Phytophthora infestans, potato blight, caused plants to wither and rot. 1 million people died, 2 million people emigrated. But this isn't just the story of the Irish potato famine and the crop vulnerability. There was actually a lot of food in Ireland at the time. And under British rule, unfortunately, that food was exported to Britain. So many of those people needn't have died. So really, this is the story of man's inhumanity to man, which is sadly boundless. And one of the few groups of people to try and help the Irish at the time in the mid-19th century were the Choctaw Native American tribe, who sent money for food to Ireland during the famine. They themselves had known awful brutality and hardship, and their kindness is remembered in this sculpture in County Cork in southwest Ireland. And the association between the Choctaw and the Irish people actually is still strong. So recently, the Irish government have been helping the Choctaw people over in the United States to cope with the pandemic. So it's often cited as a story about the vulnerability of cloned crops, but it's actually a story about something else. So sexual reproduction is great because you get genetic variation. It's much less vulnerable. Your plants, if one of them succumbs to a disease, there'll be others that survive. And pollen is the way that plants reproduce sexually. So they throw the plants like this tree and these grasses, they throw pollen to the wind, hoping that the pollen, which contains male sex cells, lands in the right place. And you might think that's an incredibly inefficient way of doing things, just sort of chuck a load out and hope it lands in the right spot. Well, it is very inefficient, amazingly inefficient. So plants have developed this other way, which is to attract an insect with a nice gaudy flower, pay it with some nectar, and in return, the insect will just go straight from flower to flower, taking to the pollen exactly where it needs to go. And now here's the tomato, which is this another member of this solanum family, like the potato, the deadly nightshade, the mandrake. For years, when it arrived in Britain, about 1590s, people they were very suspicious of this. Gerard, in his Herbal, wrote of this sort of plant with rank and stinking savor. Even though he knew the Italian and the Spanish were enjoying the tomatoes, he suggested that they shouldn't eat them, and it held back tomato consumption in Britain for about 200 years. But it has a lovely relationship with bees, and not just any old bees, but bumblebees. Bumblebees come along, they change their wing beat buzz from a normal sort of humdrum flying buzz to a middle C, and that is just the right frequency, just the right pitch to vibrate the pollen out of the flower when they clamp themselves on and beat their wings. And then they go off to the next flower, and this is called buzz pollination, and commercial growers have bumblebees on standby if they want to have tomatoes go to seed so that they can breed more tomatoes. It's called buzz pollination. Now here's the amazing thing, right? Tomato ripening can be delayed by several days by playing the harvested fruit, green fruit, a loud sound. So if you play a high C to green tomatoes for about 6 hours, quite loud, it delays their ripening for about a week. And farmers want to do this. Normally they do it with plant hormones and things, but they want to do it because it's much better to have your crop rather than a glut, have it spread out. But how on earth did Korean scientists find out that by playing loud sound to tomatoes, you delay the ripening? And this was a scientific paper only from last year. And the tomato is so full of funny, poignant, glorious scientific and human stories that it's actually the longest biography in the book. So it often pays a plant to have a faithful relationship with a particular pollinator. So they depend on each other. The pollinator gets reliable food and plant gets reliable pollination. And this is the peacock flower. Why it's called the peacock flower of Barbados, I don't know, because peacocks in my book are blue. But anyway, this is called the peacock flower. And the yellow against orange colouring of this sort of fifth petal here is especially attractive to butterflies, but less so to hummingbirds that would otherwise compete. And the flower times its nectar to when the butterflies are feeding, not the hummingbirds. And it's made the nectar tube down here irritatingly long for the birds, but the butterflies can sort of unroll their proboscis and get the nectar. So it's quite a sort of nice relationship. And I'm just going to read you a little bit about the peacock flower. The peacock flower is exuberant, but tinged with sadness too. Its seeds contain poisons that have been used by tribespeople in the region to induce abortion as a means of family planning. During the era of slavery, captive women who were expected to produce children in order to enhance the future wealth of plantations resorted to those seeds to abort their babies, preventing them from being born into a humiliating life of backbreaking cruelty. In 2018, for her royal wedding to Prince Harry, Meghan Markle's spectacular flowing veil was embroidered with distinctive flora of each nation of the British Commonwealth. Representing Barbados, the peacock flower was a poignant reminder of the slave trade and somberly resonant with the Duchess of Sussex's own ancestry. And finally, of course, the plants having flowered, they make seeds and fruit. And for a plant, they want something to come along and eat the fruit so that it poos out the seeds somewhere else with a little pile of fertilizer. And seeds are often made poisonous in some way, so that the animal won't necessarily digest the seeds themselves. And the whole thing needs to be attractive to to something that will disperse the seeds. So this is nutmeg, which is these bright red arils are very, very attractive to nutmeg pigeons that come along and disperse the seeds. And Nutmeg reached India from its home in Indonesia about 2,500 years ago. Arab traders then brought it to Europe in about the 13th century. And it's very expensive and desirable stuff. It enlivens boring food, obviously, but it's also used as an amulet. So Leonardo da Vinci in 1510, for his trip to Padua, included his list of reminders: spectacles with case, penknife, sheets of paper, scalpel, acquire a skull, nutmeg. I love that shopping list. And you probably know about the wars and skirmishes for control over the nutmeg trade that went on between the British, the French, and the Dutch. And in 1667, the British finally gave up their claim to the island of Run, which is the main source of nutmeg in what is now, or what was the main source of nutmeg in what's now Indonesia. And they gave up the claim in exchange for a hopeless little Dutch outpost in North America. And that little Dutch outpost, which they swapped for nutmeg rights, was Manhattan. In the 18th century, nutmegs were rumored to spice up physical desire and performance. So European gentlemen carried these nutmeg graters, and that, of course, all that meant that the price was absolutely sky high. See the little compartment in there for the nutmeg itself. Let me read you finally a description of nutmeg from the book, and also read you something about nutmeg that might come as a bit of a surprise. So here we go. Its flowers, though pale and inconspicuous, are fragrant and shaped like dainty urns, while the fruit are yellowish, speckled, and about the size of a tennis ball. A single tree can yield thousands in a season. At the center, in a glossy shell, sits the rough nutmeg kernel or nut that is well known as a spice. Its flavor is special, warm, woody, and thrillingly unique. The pleasure of its scent is enhanced by the intricate pattern of vessels containing the essential oils, gradually revealed by grating. Girdling the shiny nut is a succulent, lacy layer, an utterly sensual blood-red aril or seed covering, which is itself surrounded by a fleshy husk. When the fruit is ripe, the husk splits, revealing the garish aril, an alluring snack for nutmeg pigeons and their reward for dispersing the seed. The aril, which is the spice known as mace, dries to a warm beige and has a softer and more complex flavor than nutmeg. A little nutmeg is a warming delight, but a whole seed or two in one go is dangerously narcotic and widely reported to be hallucinogenic. One would need to be desperate for a high, though, since the side effects, vomiting, confusion, dizziness, and heart arrhythmia, are discouraging. It has only ever been a psychoactive drug of last resort. The African-American activist Malcolm X wrote in his autobiography about using nutmeg in jail in the 1940s. It was later banned from prison kitchens in the United States to avoid misuse, and generations of students have tried and generally failed to achieve a cheap and rewarding nutmeg high. The most common misuses of nutmeg these days are to powder it too far in advance of use or to heat it for too long. Both culinary crimes destroy its precious but fugitive flavor. Nutmeg should be grated respectfully at the end of cooking, and that way even boiled rice pudding can be a pleasure. I started with Spanish moss, and I'll finish with its close relative, the pineapple. It was so rare and expensive in the 18th century that people used to rent them out as an accessory to people to take to parties, and it entered the language to stand for anything really great. A pineapple of a gentleman. That party was quite the pineapple. I hope that this has been for you a pineapple of an evening. Today I chose plants that are familiar, but I guess with some surprising angles. I haven't had time to tell you about the more obscure ones, the mind-altering iboga from Cameroon with its strange initiation rites, the cook pine from the South Pacific that inexplicably leans towards the equator, the extraordinary tree fuchsia of New Zealand, and so on. But we do want some time maybe for questions, so I'll stop there and leave you with a final message. Water, carbon dioxide, a few other nutrients, defense, and a way to reproduce. What else do plants need? Plants need some love. They need somewhere to grow. They need somewhere to stability of climate, and they need us to recognize that they are sort of beautiful and important. I hope you've enjoyed my little botanical tour, and that if you have, you'll request and enjoy the book in your local library or your local bookshop. Thank you very much. I should say there's actually 2 books. There's Around the World in 80 Plants, and also the previous one, Around the World in 80 Trees. I'll stop sharing there. And there you go.
That was fantastic. It was very informative. I didn't realise there was so much involved with it. I should have realised, but yes, it's. I could have listened to that forever because it was really interesting.
Thank you so much.
Excellent. I'm really glad that you joined us tonight. Maybe one day after the pandemic is over, you could come and visit us in South Australia.
I would absolutely love that. When I was about 7, I wrote a book about Australia. It was called All About Australia, and I filled up a whole exercise book. In fact, so I didn't have to fill up quite so much of it. I ripped out some of the middle pages. So it was a bit thinner. And I remember I wrote about Adelaide. I can't remember exactly what I wrote, but maybe, next time I come, I'll bring it with me.
Have you still got it, have you?
Yeah, I'm in Dorset at the moment and it's in London, but I have got it, yeah.
Oh, that's fantastic. I have got one quick question before we go, so I know we're nearly out of time, and this was a personal question from me. I did read on your biography that you'd done some work with the seed bank. What did you actually do? Because I'm very interested in the seed bank. It's so mysterious sounding, isn't it?
Okay, so both for all sorts of research, but also regenerating places that have been damaged perhaps by mining or other human activities. There's an international effort to collect the seeds of plants so that if they go extinct in the wild, they can be reintroduced or, and so on. And also so we can work out how to germinate these plants. And there's the Royal Botanic Gardens in Kew, which is just to the southwest of London, has done a partnership with about 60 different countries where botanists go out, collect seeds, and then half of those seeds get stored in special seed banks, which are kind of like big fridges, really, but special kind of fridges, refrigerators. And half of them, each sample comes back to the UK. So the UK has the sort of the big bomb-proof kind of thing in the countryside, underground, and it's amazing. I mean, there are billions of seeds now from tens and tens of thousands of different species, which are sort of protected. So this is different from the crop seed bank, which is in Svalbard, sort of to the north of Norway, that you might have heard about.
That's the one I've heard about, yeah.
Yeah, they only store crop species and they specialize in that, whereas Kew has sort of everything else. And it is a sort of rather special thing, and the process of collecting them is a bit strange because most things that make seeds have flowers, and the flowers are the things that are easy to spot. But of course, you then have to come back later to collect the seeds. So people go out looking for the flowers, which are easy to find of the different plants. And then they kind of mark them with a GPS, so they know exactly where to come back to. And then they come back, a few months later to collect the seeds. And those are really difficult to find because they might be little tiny seeds on little tiny pods that you wouldn't notice unless you'd been there a few months earlier to see the flowers.
Oh, that was fantastic. It's so fascinating. As Anne has said, she's going to buy the books because there's so much information in them. So anyone that's listening, and for future people that will look at the recording, they are very interesting books, and they've got so much information in them. They're beautifully illustrated, as Jonathan has said. They're well worth reading. So put them on hold, buy them, do whatever you can to get a copy. So they're great. Thank you for joining us tonight, Jonathan. Thank you for our audience, our future audience. And I'll send some feedback forms out to the people that attended so we can get some feedback for future events as well, and also like our Facebook page if you want to know of any other upcoming events that we're doing. So thank you very much. I hope you have a great day today, Jonathan.
Thank you very much, and those people in the audience, do tell your friends to watch the recording.
Yes. Okay. All right, thank you. I'll chat later.
Cheerio. Bye-bye.
Bye.
Thank you.